Oh, okay, friends. So today we will discuss about statistics, and we will only deal with that part which is important from examination point of view as far as examination of IBBI is concerned. As far as syllabus is concerned, you have to learn introduction to statics, data classification and processing, graphical representation of data, and frequency distributions. Next, you have to study measures of central tendency, dispersion, and skewness, elementary theory of probability and probability distribution, sampling and sampling distributions, simple test of significance, regression and correlation, multiple correlation coefficient. Then you have to study time series and index numbers. So this is only that part which is significant as far as IBBI examination is concerned. So we will not deal with other part because as far as statistics is concerned, you know it is a very vast subject. So first thing you have to learn is data classification. So what is data classification? Basically, it involves organizing data into category based on specific attributes such as sensitivity, importance, and type of the data. So, first you have to classify the data according to its attribute, how sensitive the data is, how important the data is, and what is the type of the data. So, what this process will do? This process will help in managing, protecting, and utilizing data effectively. For data classification, the following steps are done. Data, first thing is you have to collect the data. So you have to collect the raw data from the various sources. Next, you have to define the classification level. Means you have to classify according to the level, whether it is a public data or internal data of a company or confidential data of a company or restricted data which is to be used by certain persons only. Then categorizing data. Then after data collection and its classification, you will categorize the data according to its appropriate category and which is based upon its attributes. And then you will apply security controls means implementing measures to protect the data according to its classification. Then you have to review the data at regular intervals so that only required data which is required in the future is kept in the storage and the other data is removed so that you have sufficient storage capacity at all times. So next is data processing. So what is data processing? Basically, it involves transforming raw data into meaningful information through various stages. So, as you know, you have already collected the data, you have acquired the data from different sources. First thing you have to do is pre-processing. Pre-processing means you have to remove the errors and inconsistencies from the data which you have collected. So cleaning and organizing data to remove errors and inconsistencies is called pre-processing. And then you have to store this data in a structured format so that it is easy to access and retrieve the data as and when required. After that, you have to process the data. So there is two things. One is pre-processing. Pre-processing mean cleaning and removing the errors and inconsistencies, whereas processing is analyzing data using algorithm models so that we are able to extract insights of the data. Then Sharing and uses means distributing the process data to the stakeholders so that they are able to make decisions according to the processed data. Then next is deletion and archiving means those data which is no longer required, they are safely disposed of so that you have enough space available with you. What are the benefits of data classification and processing? First thing, it will enhance the security of the information so that unauthorized persons do not have access to it. Then you can use this data as and when required for regulatory requirements from, and then efficiently data management. By doing so, you can simplify the data retrieval and reduce storage cost. And next benefit or the last benefit is risk mitigation. It identifies and manages risk associated with the data handling. Next in your syllabus is graphical representation, means whatever data you have processed, you can give, there are two represent the data in two formats. One format is table format, a tabular form, and second form is pictorial representation. Pictorial representation means through graphs, etc. So generally what we do, we present the data in a graphical form so that you are able to analyze the different data collected by through graphs. So there are different types of graphical representation. So by with the help of graphical representation, you can compare between different items with the help of graph. It is easier to compare the crux of the data about different items. Different type of graphical representations are as explained. First type is line graph. So basically, line graph is used to show how the value of a particular variable changes with time. So we plot this graph by connecting the points at different values of the variable. It can be useful for analyzing the trends in the data and predicting further trends. For example, we have this line graph, and the start of the period, the requirement of a product is 300 units. At the start of the first month, the demand rises to 500. At the start of second month, it comes down to 300. At the start of third month, it comes down to 100. And again, at the start of fourth month, it rises to 200. So we can represent the data in this way. The second type, which is, is your bar graph. See here, a bar graph is a type of graphical representation of the data in which bars of uniform width, these are called 1, 2, this colored portion, these are called bars. These are of uniform width, first thing is, are drawn with equal spacing between them. The spacing between them is equal. And generally we draw these on x-axis, and the height of this bar, see here, the height of this bar, first bar is 300, second bar 500, third bar again 100, and the fourth bar 200. This height represent the value of the variable, means this first bar shows the value of the variable is 300, second bar shows the value of the variable is 500, and so on. So these are bar graph. Third one is histogram. It is similar to bar graph. There are two changes between them. First thing is, in case here there is no space between the bars. See here, there is no space. In this case, there was equal spacing between the bar. Second thing is that Here it was for a particular value 1, 2, 3, 4, but here the value is for a range. Here this first bar, this range is from 300 to 400, then 400 to 500. So this will be for a range, not for a particular value. So this is similar to bar graphs, but is based upon the frequency of numerical values rather than the actual values. The data is organized into intervals and the bars represent the frequency of the values in that range. That is, it counts how many values of the data lie in a particular range. So, for example, we have this data of 400 neon bulbs. Their life is given here that for, out of 400 bulbs, 14 bulbs have life of 300 to 400 hours. 56 bulbs have a life of 400 to 500 hours. Similarly, 60 bulbs have a life of 500 to 600 hours and so on. So we can draw it in the form of histogram. See here that these 14 bulbs have a life of 300 to 400 hours. So similarly, you can draw the histogram. It will represent the this given data in a graphical form. So it will be easier to analyze the data in this graphical form. Next type is a line plot. So it is a plot that display the data as points and check marks above a number line showing the frequency of the point. For example, we have an inequality x plus 2 mod x plus 2 it is less than equal to 5. It means the value of x plus 2 lies in between minus 5 and 5. So we can write it that x plus 2 is greater than equals to minus 5 but less than equal to 5. So sorry, x plus 2 lies, the value lies between minus 5 and plus 5. So we subtract minus 2 from all of these. Minus 5 minus 2, x plus 2 minus 2, 5 minus 2 means x lies between minus 7 and plus 3. So you draw a number line 0 on the right side positive 1 2 3 4 so on, and on the left side it is minus 1 minus 2. So this line, this red line shows the variation of x. It is from minus 7 to plus 3. So this is line plot. Next is stem and leaf. So a stem and leaf is a graphical method used to display quantitative data in semi-tabular form. So it is somewhat semi-tabular form. So there are two parts in it. One part is stem and second part is leaf. Stem is that part which represents the leading digits of each data value, and leaf is that represents the last digit of each data value. So to make the thing clear, let us suppose we have a data set 23, 25, 27, 32, 36, 45, and 50. So you can create a stem and leaf plot like this. Stem, see here the values from 23 to 29. You have these three values 23, 25, 27. So this 2 will be the stem, and 3, 5, and 7 are leaf. Then from 30 to 39, you have two values 32 and 36. So this 3 will be your stem and 2 and 6 will be your leaf. Similarly, then from 40 to 49, you have only one value 45. Then here 4 will be your stem and 5 will be your leaf. And similarly from 50 onward you have only one value 50, so you can write it 5 as stem and 0 as life, leaf. So in this way you can represent this data in a semi-tabular form. So this type of graph is graphical representation is called stem and leaf. So basically, see here it what are the advantage? It retains the original data values and it helps in identifying the shape, central tendency, and variability of data. So these two things we will be discussing in the coming slides. What is central tendency and what is variability? Next type is box and whisker plot. So in this case, one thing you have to deal with is median. So as of now, we have not discussed median, so we will deal with this box and whisker plot after we discuss this part median. So next is what are the advantages and disadvantages of using graphical system means it gives a summary of the data which is easier to look at and analyze. It saves time and we can compare and study more than one variable at a time. And what are its disadvantages? So basic disadvantages we can take only one aspect of the data only and we have to ignore other data. So you will learn this thing when we are through the other slides for but as far as now is concerned, we can have that a bar graph does not represent the mean, median, and other statistics of the data. So we will learn what is mean, median, and other statistics shortly. So interpretation of graphs can be very based upon individual perspective, leading to subjective conclusion. So poorly constructed or misleading visuals can distort the data interpretation and lead to incorrect conclusions. Next, you have to study frequency distribution. So what is frequency distribution? Basically, it is a way to organize the data to show how often each value occurs. It shows how often each value occurs. So here are the main types of and the examples. First one is ungrouped frequency distribution. So let us suppose we have a quiz score of the students of, of 10 students as one student has scored 15 sorry 2 students have scored 15 marks. Then CS 17, 1, 2, and 3 students have scored 17 marks, 2 students have scored 14 marks, and then 3 students have scored 20 marks. So we can represent this data in a tabular form that score here 14, 15, 17, 20, and number of students here. So 14 marks have been achieved by 2 students. Again, for 2 students have scored 15 marks, 3 students have scored 17 marks, and 3 students have scored 20 marks. So this ungrouped frequency distribution, what it do? It lists each value and its frequency. Each value and its frequency. So this is called ungrouped frequency distribution. Next type is grouped frequency distribution. So see here, there was only one score, sorry, one forget here 14, 15. But here there will be range. Instead of one value, there will be a range. So grouped data into intervals. There was only single value. Here it is a range. Range here that let us suppose we have the ages of some persons and 18, 22, 25, 30, 35, 40, 45, 50, 55, 60. So here from 80 to 29 you have 3 persons. 18 to 39 3 person 1 2 and 3, and then from 30 to 39 again you have 2 person 30 and 35. Then from 40 to 49 you have 2 person 40 and 45. Then from 50 to 59 you have 2 person 50 and 55. And then from 60 onward you have 1 person. So this way you can show the frequency that how many persons lies in this range. Similarly, how many persons lies in 30 to 39. So group data in this what it does, it groups the data into intervals and show the frequency of each interval. Next is next is relative frequency distribution. See here, it was only how many numbers, but here you have to tell the frequency out of 10. Here you are only giving that for two students have scored 14 marks. But if you have to show how many persons out of 10 have scored 14 marks, so that will be called a relative frequency distribution. Shows the proportion of total number of observation for each value of interval. So total number of students was 14. So this 40, total number of student was 10. So out of 10 students, 0.2% we can say zero point 0.2 out of 10 for have scored to 14 marks. So again, zero point 0.2 have scored 15 marks, zero point 0.3 have scored 17 marks, and zero point 0.3 have scored 20 marks. The sum of all these will be equal to 1.2 plus 2 plus zero point 0.3 plus zero point 0.3. So if you represent the data in this form, then it is called relative frequency distribution. Next is cumulative frequency distribution. So, cumulative frequency distribution, what you do, it shows the cumulative total of frequencies up to each value or interval. See here, it is up to each value or interval. See here, the for the same ages we have done this, that 18 to 20, for interval of 18 to 20 the frequency was 3. Here the cumulative frequency will be 0. But see here, 30 to 39 the frequency is 2, means total frequency up to 30 to 39 is 3 plus 2, 5. So here up to 18 to 29 there is no total before 18 to 29, so it is 0. Then 30 to 39, 33 plus 2, 5. 40 to 49, 3 plus 2 plus 2, 7. Similarly, 50 to 59, 7 plus 2, 9. Then from 60 to 69, 9 plus 1, 10. And if you represent in this form, it is called cumulative frequency distribution. Then you have to study central tendency. So, what is central tendency in statistics? Central tendency is stated as statistical measures that represent the single value of the whole data set. It is a single value of the whole data set. So it provides an accurate description of the entire data in the distribution. So the how the central tendency is made. For central tendency, you have to find these three things: mean, median, and mode. So, how the mean is calculated? It is the average of all data points. Let us suppose you have a data set 2 plus 4, 4, 6, 8, and 10. Then mean will be sum of all the terms of the data set divided by number of terms. So 2 plus 4 plus 6 plus 8 plus 10 divided by 5, 6 is the mean of the data set. Median is basically the middle point. Basically, see here the middle point is 6. So median of this data is 6. So how this median is calculated? The middle value when the data points are arranged in, see here, first you have to arrange the data points or terms of the data in an ascending order. See here you have a data set 3, 1, 4, 2, 5. First you have to arrange it in an ascending order 1, 2, 3, 4, 5. So see here, there are conditions of finding the median. First is when you have an odd number of terms. So here odd number of terms are odd: 1, 2, 3, 4, and 5. 5 terms means odd number of terms. Then the middle term will be median. So here two terms on the left, two terms on the right, and the middle one will be your median, which is 3. But if you have a even number of terms for the data set, say for example 3, 1, 4, 2, you arrange it in an ascending order 1, 2, 3, 4, then here there is no midpoint here. And so in such case, what you have to do, you have to take the average of the middle two values. Average of the middle two values mean 2 plus 3 by 2. So median in this case will be 2.5. Next is mode. So basically what is mode? Mode is most frequently occurring value in the data set. The value which is occurring most of the time. See here in this data set, for example, 1, 2, 2, 3, 4. See here, this 2 is occurring at two times, while others have occurred only once. So this 2 will be the mode of the data set. So next is measure of dispersion. Dispersion means dispersion in statistics refers to extent to which the values in the dataset differs from the average of the dataset. See here, this is very important. That extent to which the values in a dataset differs from the mean of the dataset. So how it is calculated, we will see here. First thing you have to learn is what is range. Range is the difference between the highest and lowest value of a data set. So see here you have a data set whose value is 10, 15, 20, 25, 30. So highest value you have to arrange it in an ascending order. Then you have to take the difference of highest and lowest value means 30 minus 10. 20 is the range of the data set. For example, when you are in a real estate value, you have gone to a certain area where the prices were ranging from 50 lakh, 60 lakh, and 70 lakh. Means the range is 60 minus 20, 20 lakh. This will be the range of that property prices. Next is variance. Variance is how you can calculate the variance. See here. First, what he says, deduct the mean. Means you have to first calculate the mean. Mean of what? Mean of data set. So first you calculate the mean. Then to deduct this mean from, then deduct the mean from square of each of them. So first you calculate the mean, then you deduct it from the each value, then you take square of each and then add each square and then finally divide with the total number of values. Here what he says, let us suppose we have a data set 2, 4, 6, 8 and 10. Means what is the mean of this data set? We have already calculated 6. Then what you have to do, you have to subtract this 6 from each data value. Means 2 minus 6, 4 minus 6, 6 minus 6, 8 minus 6, 10 minus 6. Then you have to square each value. 2 minus 6 square, 4 minus 6 square, 6 minus 6 square, 8 minus 6 square, 10 minus 6 square. Then you add all these values plus. And then what you have to done? You have to divide them with the total number of values. So total number of values are 1, 2, 3, 4, 5. So your this 8 will be called variance of this data set. So next you have to study is quartile deviation, yeah, or what is interquartile range. It is the difference between the third quartile and the first quartile. So let us suppose if the first quartile is rupees 50 lakh and the third quartile is 70 lakh, then the interquartile range will be 70 lakh minus 20 lakh. Sorry, 50 lakh. So what is this quartile? We will shortly study this. What is quartile means. So next is standard deviation. Standard deviation. What is standard deviation? It is square root of the variance. So variance you have calculated this data set. If you have to calculate its standard deviation, what you have to do? You have to take its square root. So square root of 8 is really 2.83. So one thing we have left as we have all studied this median and we understand what is median. So we will use this median. And and learn this box and whisker plot which we have left. So basically, it is a way of representing, a graphical way of representing. There are three things here. What in this case, what you have to do, you have to find five values. First thing you remember. So instead of going through all these things, we will simply deal with the with this example. Here you have to find five values. What are those five values? First is lowest value in the data set, which is 75. Second value is highest value in the data set, which is 120. Third thing is you will divide it into three quartiles. First quartile is up to this 96. Here the number of terms 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So what we will do, you have this first six term as your lower quartile. We will call it as lower quartile. And then from 98 to 120, we will call it as upper quartile. So first you have to find out, so to understand lower quartile and upper quartile. So what is the lower quartile? These six terms will form lower quartile and these six terms will form upper quartile. So first thing you have to find median of this quartile. So what will be the median of this quartile? See here the number of terms 1, 2, 3, 4, 5 and 6. So number of terms are 6. As number of terms are 6 means even number of terms. So middle two values, average of middle two values means 90 plus 90 by 2. So 91 will be the median of this lower quartile. And then you have to find median of the whole data set. Second, you have to find median of the whole set data set. Whole set data set. So here there are 13 number of terms. So the middle one that is 97. So this will be the median of the third whole data set. Then you have to find median of the upper quartile. So again, see here there are six number of terms 1, 2, 3, 4, 5, and 6. So these number of terms are even number. It means you have to take the mean of these two value 100 plus 105 by 2. 102.5 will be the median of this upper quartile. So you have to find five value. First, you have to find median of the lower quartile or first quartile, then which is 91. Then you have to find median of the whole data set, which is 97. Then third median of the third quartile or upper half, that is 102.5. And then you have to find that these lower and upper values, they are called the whiskers. So minimum value is 78 and maximum value is 120. So you find out the five required values 71, 91, 97, 102.5 and 120. So now how to plot these values? First of all, you will draw a number line. So values, you see here, values varies from 78 to 120. So let us suppose we take the values from 70, 80, 90, 100, 110 and 120, because all values lies in between these lines. So your middle one, so your quartiles, median of the quartile is 91, 97 and 102.5. So first you have to draw these values. So for that you draw a rectangle here. These values lies, this value is 91 for lower quartile median, median of upper quartile under 2.5, and median of your whole data set, that is 97. You draw this rectangle. These three lines, these vertical lines will represent the quartile, the median of all the quartiles. Then you have to represent the lowest value, which is 78, which will lie somewhere here near the 80, and 120, which will lie here. So this will be the representation as a box and whisker plot. Another type is pie chart. You know what is pie chart? It is a type of graph which represents the data in the form of circular graph. The circle is divided in such that each portion represents a proportion of the whole. So next we will study skewness. So basically, what is skewness? Skewness in statistics measures the asymmetry of distribution of values in a data set. How the values are distributed and how symmetrically or asymmetrically the data of the values of the data set are distributed. There are three types of skewness. First one is positive skewness when the tail on the right side of distribution is longer than or fatter than the left side. For example, income distribution in many countries where a small number of people earn significantly more than the majority. Next is negative skew when the tail is on the left side is longer or fatter than the right side. So age at the retirement where most people retire around a certain age, but if you retire much is earlier, as in India, you know, the retirement age is 58 to 65, but in case of military, the persons are retired much earlier. And then zero skewness when the data set is symmetrically distributed. So, for example, the heights of adult in a large population, which typically follows a normal distribution. So, for calculating skewness, you have to use this formula. Skewness is equals to 3 into mean minus median divided by standard deviation. You need all these terms: what is mean, what is median, and what is standard deviation. So, if you represent it in graphical form, see in positive, right side is more longer. Here, mean is greater than median and median is greater than mode. But in case of negative skew, left side is more longer. But here mode will be having highest value, median will be having lesser value, and mean will be having lesser value than median. But in case of zero skew, all these three values will be called mean, median, and mode. So we will be taking one example. Let us suppose you have been given a data set 2, 4, 4, 6, and 6. So you have to use this formula mean, median, and standard deviation. You need three values: mean, median, and standard deviation. So first you find the mean of the data. You take sum of all the terms divided with number of terms, which is 4. So your mean is 4.5. Number of terms are 1, 2, 3, 4. So it is 4. So median will be sum of the middle two terms. 4 plus 6 by 2. Median will be 5. And mod you know most occurring value, which is 6. So mode of the data which is 6, it is having frequency 2. So if you know the standard deviation formula, first you have to calculate variance. What is variance? Means you have to subtract all the values from mean. 5.4 minus 2, you can do anything. 2 minus 4.5, because you are squaring, so it will not make any difference whether you take it as 2 minus 4.5 or 4.5 minus 2. So in this way you know how to calculate standard deviation. Standard deviation comes out to 1.658, and if you take its square root, 1.1 1.1658 will be your 1.658 is your standard deviation. So you put all the values here. Skewness is minus 0.904. So the skewness is of the data is negative. Even otherwise, see here, mean, mode, mean, median, and mode. So mode is highest, median is less than mode, mean is less than median. So from here, so you know See here from here. Mod is greatest, median is less than mod, and mean is less than median. So from here only you can understand from these three values 4, 5 and 6 that it will be a negative skew. So if you have to find it whether it is a positive or negative, just do up to this level. But if you have to find its value of the skewness, then you have to use this formula. Then next is your syllabus is elementary theory of probability. So what is probability? Probability measures the likelihood of an event occurring ranging from 0 to 1. So let us suppose for example you when the probability of getting head in a single coin toss is 0.5, because when you toss a coin there are chances 50% chances are there that it will be a head and 50% chances are there that it will be a tail. So for finding this probability, what you have to formula you have to use. The formula is first you have to find out number of possible outcomes. See here in this case, number of possible outcomes are two. One is head and other is sorry, tail. So number of possible outcomes are two, and number of attempts we can say, number of events we can say. So coin is uh, tossed once, so number of events is one. So one divided by number of possible outcomes, which is two. One divided by two, so the probability is 0.5. Then probability distribution. A probability distribution is a mathematical function that describes the probability of different possible values of a variable. So probability distributions are often depicted using graphs or probability tables. So basically, see here the difference. It is only likelihood of an event, that is probability. And probability distribution, what is probability distribution? It is a mathematical function that describes the probability of different possible values of a variable. So how in case of a variable, what will be the different values of the probability for a particular case? See here, for example, you throw a dice. Let us suppose a dice is thrown. Then the possibility of getting 1, 2, 3, 4, 5, and 6 are as follows. See here, x is a random number, is a random variable and can have any value between 1 to 6. It can have any value between 1 to 6. See here, dice is thrown, so it means number of event is 1. Number of event is 1 and number of possible outcomes 1, 2, 3, 4, 5, and 6. It means each number will have this one will having a probability 1 upon 6. So because number of dice is thrown. So here it means dice is thrown once, means number of event is 1 and number of possible outcomes are 6. In each case, this number of possible outcomes will remain same. So 1, 2, 3, 4, 5, 6 will have the a frequency of chances of getting probability is 1 upon 6. So this is probability distribution. So probability distribution is an idealized frequency distribution. So we can represent it in a graphical form that 1, 2, 3, 4, 5, and 6 each are having a probability of 1 by 6. Then there are different types of probability distributions. First type is discrete probability distribution. It deals with a discrete random variable, number of heads in a coin tosses. Discrete means a whole number. For example, if you have to note down the number of persons in each household in a locality, the number of persons will be in a whole number. So, what discrete means? Discrete means whole number. Example, it- tossing a coin three times. You have tossed a coin three times. It means number of events is three, and outcomes are that 0, 1, 2, or 3 heads. Means that if you have to calculate the probability distribution of head, it means there are means maybe out of three you may not get any head, or you may get one. You may head once, you may get head twice, or you may get head twice. So there are four number of possible outcomes. So this type of probability, it is calculated using binomial formula. So how it will be calculated, we will take an example. Another type is continuous probability distribution. A continuous probability distribution is a probability distribution of continuous variable. A continuous variable can have any value between its lowest and highest value. So basically, what is continuous probability? We will take an example. First, for calculating this uh, discrete probability distribution, we will be using this formula fx n x p raised to power x q raised to power n minus x, where p is the probability of success in an individual trial, q is equals to 1 minus p is the probability of failure, n is the number of trials, and x is the number of success from n trial. This formula, what this n and x, so basically it is not n upon x. This nx, it shows n factorial in the numerator, and x shows x factorial into n minus x factorial. So we will try to make the things clear with an example. Let us suppose, given that only 20% of all adults can pass a specific cognitive test, what is the possibility that five randomly selected adults, three of them passed this test? So here, what is the probability? Probability is that 20% of the person will can pass. So P is zero point 0.2 chances of getting passed, and Q is probability of failure. Probability of failure will be equal to 1 minus probability of success. So 1 minus zero point 0.2, Q is zero point 0.8. And here, how many number of persons you have selected? 5 randomly selected adults. So N is 5. And you have to check 3. 3 is how many persons can pass the test. That is X, it is 3. So you put all the values in this formula, so it comes out to be 0.05, means there is 5% probability that 3 out of 5 randomly chosen adults will pass the cognitive test. So this is how you can calculate probability distribution, that is continuous probability distribution. And this continuous probability distribution, basically, let us suppose, so here it was a particular value 5%, but here it will not be a possible value, a whole number. See here in the question. So as we have discussed that in case of discrete means whole number. So the probability was whole number, but probability distribution was whole number. But here in continuous probability, a continuous variable can take any value within some interval. So let us suppose you have to find you go, and there are upper and lower limits in human height and weight, we know, but in those limits there are infinite number of possible heights and lengths. For example, two pupils may have the same height, 5 feet 8 inch, but it is unlikely that their weight is also same. Instead, their height probably varies by some decimal and cannot be made precisely. So their height and their maybe that their weight is same, and but their height may not be same. So here instead of particular value, here we will be giving a range. So for in this case the values may be that 5 feet 8 inch having a weight of 60 kg and the second person having a weight of height same as 5 feet 8 inch but having a weight of 60.1 kg. So we donate it with the px. So it is say let us suppose you are finding the some intervals where you have for example you are noting the heights of the persons in inequality between heights 5 feet to 6 feet. So let us suppose if no person has a height of 5 feet 10 inch, then p 5 feet 10 inch will be equals to 0. So this equation may be 0 if that we are not able to find that particular value. So in case of continuous probability distribution, so let us suppose this is an equation that x lies between a and b. So this probability that an outcome x lies between the interval a and b is represented by shaded area under the curve. So, for instance, consider the continuous probability distribution of women's weight. While the probability distribution across populations suggests that average woman weight is 60 kg, but it is impossible to find a woman which is weighing precisely 60 kg. It is practically possible that so maybe that woman has a weight of 60.5 kg or maybe having a weight of 59.8 kg, but it is very remote chances that he is having an exactly the weight of 60 kg. Next is time series. A time series is a sequence of data points collected or recorded at successive points in time, usually at equally spaced intervals. This type of data is used to track changes over time and can be applied in various fields such as finance, economics, weather forecasting, and engineering, etc. The following aspects must be known to you. What is temporal ordering? First thing is temporal ordering. The data points are ordered in time, making the sequence crucial for analysis. Then analysis method. There are different analysis methods that includes trends includes techniques like trend analysis, seasonal decomposition, and forecasting, etc. Then where these time series are used, these are used in stock markets, sales forecasting, or climate studies, or earthquake studies, and many more cases these are used. For example, that this example will make the things clear. Imagine you record the temperature at noon every day for a month. The list of these daily temperatures forms a time series. Here is a small example that on 10th January 2024 the temperature was 25. On 10th February 2024 temperature was 26 and so on. So see here date interval is same and these temperatures are varying. These are the data points. Temperatures are the data points. By analyzing this time series, you can identify patterns, trends, and possibly make decisions about the future temperatures. So time series are used for identifying patterns, for identifying trends, or making future predictions. Next is index number. So index number as a value, you all of you know what is index number. You have been using these numbers in capital gain valuation. So things which you must know. Okay, what is index numbers basically? These are statistical measures used to show changes in variable or a group of a related variable. There are two things. One is variable and other thing is group of a related variable over time. They are commonly used in economics to track economic performances, inflation, and productivity levels. So key features of index numbers are relative measures. Index numbers measures relative changes rather than absolute changes. So base period, they compare the current data to a base period which is usually set to 100. Common types of price index are include wholesale price index, consumer price index, cost inflation index, which you use for calculation of capital gain tax, quantity indices, and value indices. So they are used to track changes in prices, cost of living, industrial production, etc. So, as an example, let us suppose that in the base year the price of a commodity was rupees 50, and the index number on that base year was 100, and in the current year, say in 2024, the price of that commodity is 300. So it means that the value of that or the price of that commodity has increased by 600%. There is an increase of 600% in the price of that product. So the index number of the current year will be 600. So relative to this number, how many times the price of that commodity has increased, that will be the index number. Next thing you have to study is correlation. What is correlation? Basically, it measures the strength and direction of a relationship between two variables. Let us suppose there are two variables x and y. So, how they relate to each other, whether are moving in the same direction or whether they are moving in the opposite direction. Let us suppose there are two types of correlation. First one is positive correlation. So if x and y are moving in the same direction, means if x increases, y is also increases. It will be called positively correlated. An example of this would be demand and price. As the demand increases, price of that commodity will also increase. So we will say that they are positively correlated to each other. Then negative correlation is opposite of positive correlation. Means if one increases, the other one will decrease. Suppose two variables are moving in the opposite direction. Like when an increase in one variable result in decrease in another. This is known as a negative correlation. An example is price and demand. As the price increases, demand will decrease. So we will call them they are negatively related to each other. Correlation coefficient. Correlation coefficient shows how variables are related. We find the correlation coefficient, and the correlation coefficient lies between -1 to +1. It quantifies the relationship. See here, it was only it has positive and correlation, and negative correlation gives you the direction and strength. But the coefficient, it gives you the quantifies their relationship. A value of 1 indicates perfect positive correlation. Both variables move in the same direction. 0 means no correlation, and -1 indicates a perfect negative correlation. So how this correlation is calculated? Let us suppose you have a data set, a value of x 50 at 50, the value of y is 3.1 at 51, the value of y is 3.2 at 52, value of y is 3.3, and so on. So you can directly find this correlation of this series with the help of Excel. This is a formula equal to correl. You will insert this formula, then 50 to 54, 5 means F5 K5, it shows 50, 51, 52, 53, these values, comma 3.1, 3.2, 3.3, 3.4, 3.5, it shows F6 to J6. You put these values, it will automatically give you the correlation, which is 1. It means they are perfectly correlated to each other positively. Then next thing is regression. Regression, it quantifies how one variable affect the others. So see here the difference. It shows the how they are related. But regression, it quantifies how one variable affect the other. So let us suppose an example. This would be an increase in rainfall. So no, you know, if there is an increase in rainfall, it will cause crops to grow. More crops will be grown if the rainfall is more. So just like a drought would cause crops to wither, not to grow. So how the next thing is regression coefficient. So how regression coefficient? What is regression coefficient and how it is find out? Regression analysis models that relationship between a dependent variable, that is the outcome, and one or more independent variables predictor. So the regression coefficient or slope quantify how much the dependent variable changes for every one unit change in the variable. So the regression formula is y equals to a plus b into x. It means a refers to y-intercept when the value of y means the value of y when x equals to 0. B refers to the slope or rise over run, and the prediction formula is y equals to a plus b. So let us suppose we know the formula is a plus b into x. You from the various data you calculated that y is equals to 65.47. This is constant, and b 2.58 into x, where x is a variable. It shows that for each additional hour of study, the exam score increased by 2.58 point. Means that if x is if value of x is 1, then the value if the value of let us say the value is z, and then if x value of x is 2, then it will be equals to 2 to z plus 2.58. It will increase by an amount 2.58. Then multiple correlation coefficient. So yes, it is regression coefficient, correlation coefficient, and next one is multiple correlation coefficient. Multiple correlation coefficient measures the strength of a relationship between one dependent variable, say here one dependent variable, and two or more independent variable. In that case, in here correlation there was only two variables x and y, but here one dependent variable and two or more dependent independent variables means there will be three or more than three variables here. For example, predicting a student's academic performance, it is a dependent variable. So it is based upon three more variables. One is study hours, second one is attendance and homework. So this academic performance, which is dependent variable, it is based upon three independent variables, which is study hours, attendance, and homework. So as the study hours increases, academic performance will improve. As the attendance increases, study academic performance will improve. Similarly, homework increases, academic performance will improve. So let us say after some calculation you find multiple correlation coefficient 0.90. It suggests that strong positive correlation, that more the hours study, higher the attendance and more homework completed, the better their exam scores. Next is sampling distribution. Sampling distribution of a statistic is a type of probability distribution created by drawing many random samples of a given size from the same population. These distributions help you to understand a simple static varies from sample to sample. So sampling distribution is basically it is probability distribution of values of statistics. If you have to understand it in simple forms, you have to remember this, that simply sampling distribution is probability distribution of Values of static. Static means what? Static means mean, mode, median, or variance, standard deviation, etc. So these are statistic of a data set. So sampling, what is sampling distribution? It is probability distribution of what? Values of static of a particular data set. For example, sampling distribution of some sample mean, sample distribution of sample median, etc. For example, let us suppose we have a sampling data 2, 4, and 6. So see here, population means number of terms of the data are 3. Let the size be n equals to 2. So number of groups you require, number of samples you require, n raised to power n means 3 raised to power 2 means you require 9 samples. So first sample is that you have 2 comma 2, 2 comma 4, 2 comma 6, 2 4 comma 2, 4 comma 4 means you have these two samples. 2 2 2 2 4 2 6 4 2 4 4 4 6 6 2 6 4 6 6. You calculate the mean of these, all of these. 2 plus 2 by 2 equals to 4. You find mean of these. Now you simply write down that mean of frequency. So 2 is here for how many times? One time. See, 3 is 2 times, 3 and 3. 2 times. You will write frequency of the mean. This is mean, this is frequency of the mean. X bar is frequency of the mean. 4, frequency of the frequency is 3. 1, 2, and 3. Similarly, you find the frequency of 5 and 6. So this is frequency of the mean. Then you find f. Uh, this is frequency of the mean. 2 is having 1 time, 3 is having 2 times, 4 is having 3 times. So this is fx is frequency. These are means. Only one time you have to take these means. Then fx. So total number of sample is 9. So there are chances that 2 will come, fx divided by number of possible outcome, 1 upon 9. This will be 2 upon 9. This will be 3 upon 9 means 1 upon 9. Similarly, you can find the probability. So this is sampling distribution. So see here, there are two things. One is sampling distribution. In sampling distribution, you will be taking values of static. Another thing is sample distribution. Second thing is sample distribution. Sample distribution is probability distribution value of the sample. Not see here, we are taking statics, means we are finding mean, let us suppose. But here you have to simply find the probability distribution of value of the sample. Let us suppose you have a sample 2, 2, 5, 2, 3, 2. So total number of turns are 1, 2, 3, 4, 5, 6. So see here how many times you have to find the frequency of each term. 2 is frequency of 2 is 1, 2, 3, 4. Frequency of 3 is 1 and frequency of 5 is also 1. You find the probability. Probability means 4 divided by 6. Okay, then 1 divided by 6 and 5, 1 divided by 3 divided by 6, it will be 1 by 2, 2 divided by 6, 1 by 3. You, in this case, you can find probability in this way. Then this is probability distribution of sample. There is difference between sampling and sample distribution. In sample, you will be taking the probability distribution of the given sample, but in case of sampling, you will be taking the probability distribution of some static, maybe mean, maybe median, maybe mode, maybe some other things. And then the last topic in your syllabus is simple test of significance. If its result is status, you have to check if you are doing some research, you have to check that your result is statistically significant. It means unlikely to be explained solely by chance or by random factor. In other words, statistically significant result has a very low chance of occurring if there was no true effect in a such study, or if the result is not statistically significant, the search study will not have any true effect. So to make the things more clear, we will be taking some example. So basically, there are two things. One is null and other one is alternative hypothesis. For null you mean null is zero. So first, what we say, first we find out a null hypothesis, which is denoted by H0. It always predicts no true effect, no relationship between various variables, no difference between the group. And second is an alternative hypothesis. We denote it with HA or with H1. So let us suppose, for example, you a pharmaceutical company launches a new medicine. They conducted a research in the market, a survey in the market, and they found out that already available similar drug having the same price is being used by 20% population. Then null hypothesis. Hypothesis will it means what null hypothesis means? They will assume that the new drug will be used by same 20 number of persons which you have calculated from your research. Alternative hypothesis, it means the company can be able to sell the product more than 20% persons at the same rate. So if they are able to achieve this 20% target, so it means they are they have this is comes under null hypothesis, and if they are able to achieve more target than that, then it means they are able to have this an alternative hypothesis. So for that, t values and p values are calculated. How these values are calculated, and to make the things more clear, we will take one example. So one thing should be clear that either there will be null hypothesis applicable or alternative hypothesis applicable. It is not possible that both of them are applicable at the same time. They are opposite to each other. So we will taking an example. A researcher knows that average height of Manipur women is 1.53. So this is from the previous research. It has been found that the height of a Manipur woman is 1.53 meter. But they conducted a random sample and take of 26 women was taken and found that their mean height is 1.56 meter with a standard deviation of zero point 0.1 meter. Is there a reason to believe that the 26 women in the sample are significantly taller than the others? So this you have to check. So for that we will be assuming first that the null hypothesis exists. So we will be for as you calculating or finding this null and alternative hypothesis. And if a null hypothesis is applicable, then it is not needed to find out or do or find out alternative hypothesis. So given here, it means that mu. So see here, what is mu basically? There are some things. So see here, mu is a mean average height. of the Manipur women, which is it is less than or equals to 1.53. So this mu should be average height is 1.53. It should be less than equals to 1.53. Means just as we have already discussed that in case of drug, already drug was used by 20%. Our new pharmaceutical companies, new drug will also be used by 20%. So in null hypothesis, you will assume that the height of Manipur woman is less than or equals to 1.53. This is a null hypothesis. And your alternative hypothesis will be it, that average height of the Manipur woman is more than 1.53 meters. So this corresponding to right tail test, for which t-test for one mean with an unknown population standard using the simple standard deviation will be used. So data is given to us that alpha is 0.05 and df you have to find it is equals to n minus 1. N is the number of persons in a ward in the sample 26 minus 125. So you will find the value of t. C TC for TC the formula is DF is 25, alpha is 0.05. So to put this formula for finding the TC, this is T dot INV 25 comma 0.05. You put the values, this TC will come out to be 1.70814. So it means TC means it is greater than T should be greater than 1.70841. Then you find the value of T. Formula for T is x bar minus mu divided by S divided by under root of L. X bar is mean height of the sample, which is 1.56 meter. Mu is average height of the previous data, which is 1.53. Then SS is standard deviation, which is given to you as zero point 0.1. N is number of samples, which is 26. You put all the values, so value comes out to be 1.5297. So this value is less than 1.70181. It means your null hypothesis holds good. So it is then concluded that null hypothesis is not rejected. Then we will further check it with p-value approach. For p-value approach, formula is df is 26, alpha is 0.05, t-value is 1.5297. So for p-value formula is t dot dist dot rt. You put the value TF comma T value. You put this value, the T value, P value will come out to be 0.069084. So this value is greater than alpha, which is 0.055. 0.05. It is concluded that null hypothesis is not rejected. It means that null hypothesis prevails. So we do not need to go for alternative hypothesis. So therefore, there is not enough evidence to claim that population mean mu is greater than 1.5 times at the alpha, which is 0.05 significance level. So this is all which you need to know about statistics as far as this IBBI syllabus is concerned. Thank you very much. Have a nice day.